Now next topic is fundamental theorem of definite integrals. So here theorem is explaining this statement by an example. Say we know that indefinite integral of cos x, it is equal to sin x plus c. Integral of cos x with respect to x is sin x plus c. Now we want integral of cos x. Now we want a definite integral over interval 0 to pi by 4, or suppose pi by 6 to pi by 3. So we need definite integral of cos x over interval pi by 6 to pi by 3. This number is lower limit, this number is upper limit. So we are finding a definite integral over closed interval pi by 6 to pi by 3. So method is put integral in a rectangular box. This is integral. Then at the lower corner of this box keep here lower limit, and upper corner of box keep upper limit. Then substitute this value in this integral. So this is value of x, these are values of x. C is constant, it is free from x. So put wherever you have x, upper value and then lower value. So first of all we put upper limit. So sin pi by 3 plus c. Then take difference, take minus, then lower limit, put lower limit. So sin pi by 6 plus c. So it is equal to sin pi by 3 is root 3 by 2. Say this c will be cancelled, minus 1 by 2. So I am putting this in detail. Sin pi by 3 minus sin pi by 6. So its value is root 3 by 2 minus 1 by 2, root 3 minus 1 by 2. Now see what is happening here. Whenever we find indefinite integral contains arbitrary constant, and if you include arbitrary constant in finding a definite integral, after substituting upper limit then minus taking a lower limit, every time whatever will be here arbitrary constant, it will be cancelled. So this is, see, it is nothing but value of, if I do not include c, if suppose I do not include c, if I keep only sin x, I do not include c, if I keep only sin x, lower limit pi by 6, upper limit pi by 3, then we are getting this value. So that means in general rule can be expressed as if integral of fx, indefinite integral of fx is capital Fx plus c, capital Fx plus c, integral of small fx indefinite integral of small fx is capital Fx plus c, then definite integral of same function over interval a to b, it is equal to, now observe here, keep a box, means keep rectangular bracket. In the rectangular bracket, put capital Fx. So in the rectangular bracket, put capital Fx. No need to put c. Lower limit keep at lower end, upper limit keep at upper end. So its value is f of b minus f of a. This is f of a, capital F of a minus capital F of b. So it is equal to upper limit put b minus, then put lower limit fb minus fa. So this is f of b minus f of a. So this is said to be fundamental theorem or fundamental principle of definite integral. So now we are doing sums on this theorem. So only the new thing is, don't include c. After putting integral in the rectangular bracket, put upper limit minus lower limit, that is only extra work. As for example, suppose integral of 1 to 3 x square dx. So to find a definite integral of this function over 1 to 3, integral of x square is x cube plus c. It is indefinite integral. But when we find definite integral, don't include c. Its integral is x cube by 3. Then don't put c. Close this bracket. Lower limit is 1, upper limit is 3. So this is 27, put upper value 27 by 3 minus, then put lower value 1 by 3. So 26 by 3. Suppose we want integral of sec x dx. Integral of sec x, suppose I keep here 0 to pi by 4. Now, integral of sec x is, indefinite integral is log mod sec x plus tan x plus c. This is indefinite integral, but don't put c. When finding definite integral, keep value without c in rectangular box. Lower limit, here put upper limit. Then substitute upper value. So log of, put here x equal to pi by 4. Log mod sec pi by 4 plus tan pi by 4. So this is taken. Now minus, then do minus, then put lower limit. So putting 0 here, log mod sec 0 plus tan 0. So this is f of b minus f of a. So it is equal to log mod sec pi by 4 is root 2, tan pi by 4 is 1 minus log mod sec 0 is 1, tan 0 is 0. So log of root 2 plus 1 minus log 1. Log 1 is 0. So this is log of root 2 plus 1 minus 0. So log of root 2 plus 1. Suppose we want integral of next question is integral of sec square 3x. Here I kept 0 to pi by 4. Now integral of sec square 3x. So integral of sec square 3x is tan 3x upon 3. Integral of sec square x with respect to x is tan x. But because this is 3x, coefficient of x is 3 divided by 3. So this is indefinite integral. But when finding definite integral, we do not include c in this bracket. Keep here a lower limit, keep here upper limit. So this is equal to, now putting upper limit, see here 1 by 3 we can take outside, because in difference this will be common. When taking difference f of b minus f of a, this is constant, so it will be common. So taken common. Now inside, in the remaining part, put upper limit tan 3 pi by 4 minus tan 0. That is 1 by 3 into tan 3 pi by 4 pi minus pi by 4. Second quadrant. So minus 10 pi by 4. Minus 10 pi by 4, that is minus 1 minus 0. So value is minus 1 by 3. Suppose we want integral of e raised to 3x plus 5 on interval 0 to 6. Now its integral is e raised to 3x upon 3 plus integral of 5 is 5x. Lower limit 0, upper limit 6. Now putting values, putting upper limit e raised to 18, 6 into 3 18 by 3 plus 5 into 6 30. F of b. Now difference minus, put 0. So e raised to 0 by 3 plus 5 into 0, that is 0. So it is e raised to 18 by 3 plus 30 minus 1 by 3. E raised to 0 is 1. So e raised to 18 by 3 plus 30 into 3, 90. 90 minus 1, 89 by 3. So 1 by 3 times e raised to 18 plus 89. So meaning of fundamental theorem of definite integral. Definite integral of 1 upon x square minus 1 over interval 2 to 3. Now say 1 upon x square minus a square. So applying formula 1 upon x square minus a square, 1 is 1 square. So it is 1 upon 2a. This is our a square, 1 square. So 2a log mod x minus a upon x plus a. To find definite integral, first of all we keep value of indefinite integral without c. Put this value in box. Here keep lower limit, here keep upper limit. Now we are taking difference, putting upper value, that is f of b minus f of a. So in this difference, this number will be common. So keep inside 1 by 2, it will be common, keep inside. Now putting upper limit, log of modulus 3 minus 1 is 2 upon 3 plus 1 is 4. Then minus log of modulus, now lower limit, putting it 2 here, 2 minus 1 is 1 upon 2 plus 1 is 3. Because these numbers are already positive, if you don't keep modulus, then it is allowed. Means you can put this free from modulus. You can put like this. So that we do in next step. So it is 1 by 2 times. This is log of 1 by 2. Now we remove modulus. Minus log of 1 by 3. So it is equal to 1 by 2 times log of log A minus log B is log of A by B. This is 1 by 2 times log of 3 by 2. So this is required definite integral. It can be also expressed as log of square root of 3 by 2, because this is a coefficient of log, it comes as power. So 3 by 2 raised to half, that is square root. So this is required definite integral. Now here cos square x. Whenever we want to integrate cos square x, always we remove this even power. Using formula, cos square x is 1 plus cos double x by 2. Cos square x is 1 plus cos double x by 2 dx. Lower limit, upper limit. Say this is constant, we can keep it outside. So this 1 by 2, from the beginning we keep it outside. So simply you can put as 1 by 2 times 1 plus cos 2x. Now 1 by 2 keep inside. In box we put integral. Integral of 1 is x. Integral of cos 2x is sin 2x by 2. Close the bracket. Here lower limit, here upper limit. That is equal to 1 by 2 times. Now by fundamental principle of definite integral, upper limit minus lower limit. So put pi by 2. So pi by 2 x pi by 2 plus sin 2 into pi by 2. That is sin 2 into pi by 2 is pi by 2. So upper limit is taken. Here 2 into pi by 2 is pi 2 as it is. Minus lower limit. Putting here 0, 0 plus sin 0 by 2. That is 1 by 2 into pi by 2 plus sin pi 0. This value is also 0. So everything 0. So this is pi by 4. Now here say this is x square plus 1 and numerator is x, and we know that derivative of x square plus 1 is 2x. Derivative of x square plus 1 is 2x. So derivative of denominator can be created in the numerator. Only 2 is missing here. So what we do? Divide by 2. Outside divide by 2, inside multiply by 2. So if this is function f, then this is its derivative, f dash. So 1 by 2 times integral of f dash upon f. Integral of f dash upon f is log of modulus fx. Put in box here 2, here 3. So that is 1 by 2 times, now upper limit, log of 3 square is 9, 9 plus 1 is 10, minus lower limit, 2 square is 4, 4 plus 1 is 5. So this is 1 by 2 times log of 10 by 5. So 1 by 2 times log 2. So this is log of root 2. So answer can be shown in these two forms. Now see here, this question can be done by second method. Method of substitution. Second method, method of substitution. In this method, what we do, we take substitute. Say to remove this x dx, we take x square plus 1 equal to t. Taking x square plus 1 equal to t, that means 2x dx is dt. That is x dx is dt by 2. So this part can be removed by dt by 2. So integral is, see, x dx is dt by 2 and this is t, x square plus 1 is t. So this work we were doing in previous methods in finding indefinite integral. But now keep remember, when we change variable, this is now in a new variable t. So this should be interval for a new variable. This was interval for x. See, original variable is x. So here x belongs to 2 to 3. But as we have changed variable, we have to keep here range for t, where t belongs. Where does t belong? So to change this limit must be changed. Don't forget to change this limit. These are values of x. We have to put here values of this variable t. So this is new variable, so put here values of t. So to change limit, here two lines. When x is 2 and when x is 2, at that time putting here 2 square is 4 plus 1 5, t is 5. So when x is 2, t is 5. Now upper limit, when x is 3, t is 3 square 9 plus 1 10. So 3 you replace by 10, 2 replaced by 5, t replaced by 10. When dx is replaced by dt. So this is the procedure when we use method of substitution. So it is equal to 1 by 2 times log of modulus t. Integral of 1 upon t is log modulus t. So here 5, here we keep 10. So 1 by 2 times log of a 10 minus log of 5. So as done here, it is 1 by 2 times log of 2. So log of root 2. So this is required definite integral. Now say integral of 2x plus 3 upon 5x square plus 1 over 0 to 1. Say look here, this is 5x square plus 1 and here it is 2x. So in the beginning, to integrate this, what we do, we divide this separately. So it is equal to 0 to 1 2x upon 5x square plus 1 dx plus 3 into dx upon 5x square plus 1 0 to 1. So 2x upon this number plus 3 upon this number, and distribute this symbol individually with dx with the lower and upper limit. Working rules are same. Integral of fx plus gx is integral of fx plus integral of gx. So this can be separated if here sum of functions or difference of functions given. Now here think about its derivative. Derivative of 5x square plus 1 is 10x. So we can set 10x in numerator. So to have here 10x, we have to multiply this by 5. So divide by 5, multiply by 5. Multiplied by 5, so divide by 5. 5x square plus 1 dx plus 3 into, now see, from denominator I am taking 5 common. Taking 5 common, this will be x square plus 1 by 5. So it is x square plus 1 by 5. So we can apply here formula 1 upon x square plus a square. Now 1 by 5 is root 5 whole square. So 1 by 5 can be seen as 1 by root 5 whole square. Now this is f. This is f dash, and integral of f dash upon f is log of modulus f. So its integral is 1 by 5, keep as it is. Its integral is log of modulus 5x square plus 1. Put here bracket, lower limit 0, upper limit 1, plus 3 by 5 into integral of 1 upon x square plus a square. Integral of 1 upon x square plus a square is 1 upon a tan inverse x upon a. 1 upon a tan inverse x upon a. Keep this integral in box, lower limit 0, upper limit 1. Now 1 by 5, putting here 1, so log of 5 into 1, 5 plus 1, log 6 minus log 0. Now put lower limit, so log 0 plus 1, log 1. So upper limit minus lower limit plus, now this is a constant, it will be common in difference, so take it out. So this comes outside, so it will be 3 root 5 by 5. Now upper limit minus lower limit, so tan inverse, put here 1. So 1 upon 1 by root 5 is root 5 minus, put 0, so tan inverse 0. Upper limit minus lower limit, that is, now log 1 is 0, so 1 by 5 log 6 plus this will be 3 by root 5 tan inverse 5. Tan inverse 0 is 0, so it is 1 by 5 log 6 plus 3 by root 5 tan inverse root 5. So this is required definite integral. Here in this question, this part you can also solve by taking 5x square plus 1 equal to t, substitute. So in that case, this 2x dx can be removed. But when you take substitute, the lower limit and upper limit must be changed, as just I have shown in last question. So interval, it should be value, set of values for new variable. Now here, so this is e raised to x square, e raised to x square, and in the list of formula we don't have any result to integrate e raised to x square. So what we do, we take x square equal to t, substitute, take x square equal to t, taking x square equal to t, 2x dx is dt, and look, this x dx is going to remove, so it is equal to x dx dt upon 2. So integral is x square is t, x square is t, x dx is dt upon 2. But when we take substitute, this limit will also be changed. Original variable was x, these are values for x, now we are in t, so here we should keep value of t. So to find corresponding value of t, if x is 0, when x is 0, t is 0. When x is 1, upper limit is 1, so put here 1. When x is 1, t is 1. So 0 will be replaced by 0, 1 will be replaced by 1. Here we are getting same values, so it looks the same. Now its integral is, integral of e raised to t is e raised to t. Put here 1 by 2, 0, 1. So this is 1 by 2 into e raised to 1 minus 0, e raised to 1 minus e raised to 0. So this is 1 by 2 into e minus 1. Now say here, square root of sine phi into cos raised to 5 phi with respect to variable phi. Say here cos has an odd power, so out of this 5 power, 1 cos, it can be removed with d phi. Taking substitute sine phi equal to, we can take t, you can take also t square, both are allowed. So if we take sine phi equal to t, then cos phi d phi, cos phi d phi is equal to dt. And when we change variable, we have to change its limit also. These are values of phi. So when phi is 0, at that time putting here 0, t is sine 0, that is 0. And when phi is pi by 2, putting here pi by 2, sine pi by 2 is 1. So here integral is 0 to pi by 2. Before putting these values, here rearranging these numbers, root sine phi, this is cos raised to phi, so cos raised to 4 phi into cos phi d phi. One cosine is separated from 5 power, this is separated because it will be removed with d phi. This part will be replaced by dt, and we want to use sine phi is t, so now this can be converted into sine. So 0 to pi by 2 square root of sine phi cos raised to 4, that is cos square whole square. Cos square is 1 minus sine square, this is cos square raised to 2, that is cos raised to 4 into cos phi d phi. Now putting values, putting values, here integral is, here now we require space, so I am removing this question. So integral is now look, 0 will be replaced by 0, pi by 2, this pi by 2 will be replaced by 1, because phi we are converting into t. So now here this is sin phi is t, 1 minus t square whole square, sin phi is t, at that time cos phi d phi is dt, and these are values of t. So it is completely in terms of t. So it is equal to 0 to 1, this is t raised to half, here 1 minus 2t square plus t raised to 4 dt. Now expanding this, it is t raised to half minus 2t raised to 5 by 2 plus t raised to 9 by 2 dt. So that is, now it is integrable. This integral is t raised to 3 by 2 upon 3 by 2 minus 2 into t raised to 7 by 2 upon 7 by 2. So 2 into 2, that is 4, plus t raised to 11 by 2 upon 11 by 2. So now putting this in box, lower limit 0, upper limit 1. Now substitute upper and a lower limit, putting 1 here. So 2 into 1 is 2 upon 3 minus 4 upon 7 plus 2 by 11. So that is 1 is replaced in place of t, and 1 raised to anything is 1, minus putting here 0 0 0, second part will be 0. So it is equal to, now LCM of 7, 3 and 11, you can calculate this expression. Now see, minus 1 to 1, 1 upon x square plus 2x plus 5. In this method, here we split up 5 in such a way that we get perfect square polynomial. So this can be expressed as x square plus 2x plus 1 plus 4. So this part is now perfect square. So it is minus 1 to 1 dx upon, it is x plus 1 whole square plus 2 square. Now we take substitute, take x plus 1 equal to t, x plus 1 is t, so dx is equal to dt. Now we change limit when x is minus 1. If you keep here minus 1, so t is 0, and when x is 1, if you keep here 1, t is 2. So integral is, therefore integral is, say dx is dt when x plus 1 is t, so put here t, and because now new variable is t, we change the limit. Minus 1, it will be replaced by 0, 1 will be replaced by 2. So don't forget to change this limit when you change variable. Now its integral is 1 upon a tan inverse x upon a. So 0 to 1 upon x square plus a square, 1 upon a tan inverse x upon a. Now 1 by 2 is constant, so we can keep this outside. In difference this will be common, so keep out of bracket. Now upper limit, putting here 2, 2 by 2 is 1, and here 0 by 2 is 0. So 1 by 2 times pi by 4 minus 0, so it is pi by 8. Now see here, we apply rule of integration by parts. X into e raised to x. This can be done by two methods. It can be done also by rule of integration by parts, and other method is, let me first explain. We understand by rule of integration by parts, how rule of integration by parts can be applied in this method. See, L I A T E, x is algebraic, e raised to x is exponential. So set this number as u and this number as v. So u as it is integral of v minus integral of box in box derivative of u integral of v and integral of this product. So this is by rule of integration by parts. Now because we are finding definite integral. Now where should we keep these limits? If you keep here 0 to 1, 0 to 1, then after few steps at last you will do here mistake, because x is outside. So in calculation you will miss to include this x when you put 1 and 0 in integral. So x will be remain inside. But remember, in definite integral answers are constants. Value of a definite integral must be free from x. So if you miss to put here value of upper limit and lower limit, because this is variable, your answer will be wrong. So to avoid mistake, what we do, when you apply integration by parts, do not forward these values by this method. Here don't write 0 to 1, 0 to 1. Instead of that, what we will do, put here big bracket, rectangular bracket, keep big bracket, put here lower limit, put here upper limit. So when we shall use this trick, when you apply rule of integration by parts, inside nowhere you keep these limits, you keep limit at lower and upper corner of this box. Everything you keep in box. Now simplify inside and continue this box as it is. So x into integral of e raised to x is e raised to x minus integral of, this is 1 into, this is e raised to x dx. So simple form of this is e raised to x, 1 into e raised to x, 0 to 1. So it is equal to x into e raised to x minus e raised to x, 0 to 1. Now at last, when final symbol of integration is removed, at last you keep upper limit minus lower limit. Now we keep upper limit. So 1 into e raised to 1 is e raised to 1 minus e raised to 1. This is upper limit minus. Now lower limit, 0 into e raised to 0 minus e raised to 0. 0 into e raised to 0 minus e raised to 0. First of all, what we have taken? We have taken 1 into e raised to 1 minus e raised to 1. So this is 0, 0 minus, this is 0, this is minus 1. So final value is plus 1. Now this question can also be done by second method, method 2. Say here 0 to 1 x into e raised to x dx. Say 0 to 1 x into e raised to x. Whatever is given, I have repeated. Now because here e raised to x given, inside here we can split up this x in two parts such that one part is f, other part is f dash. Now whatever is given, this x keep in first part. Now what is derivative of x? Derivative of x is plus 1. So put here plus 1. F dash side keep plus 1. Derivative of x is 1. But we cannot change value. So whatever you have added, you have to subtract same value. So put here minus 1. Now this we are considering as f. So here there should be f dash. Now check, derivative of x is 1, and what is derivative of minus 1? 0. So imagine here 0. So in short, derivative of x minus 1 is 1, means if this is f, this is f dash. So x is expressed as sum of two functions. One part is f, other part is f dash, and we know rule that integral of f plus f dash times e raised to x is fx into e raised to x, fx into e raised to x, 0 to 1. So that is putting upper limit 0 into e raised to 0 minus putting lower limit minus 1 into e raised to 0. So value is 1. Definite integral of this function over interval 1 to 2. Now look the pattern of this function. See here you can see e raised to 2x, and here functions, sum or difference of two functions. So by looking this type of integral, you should remember, you should find its matching with fx plus f dash x e raised to x dx. We can convert in this pattern to this function. Now to apply this formula, here there must be x. This is any function of x. Here any function, any combination of x allowed, but over e, here power x is must. And in this question over e, 2x is given. So to convert in that form, we are taking 2x equal to t. Taking 2x equal to t, we will have then e raised to t. So 2x is t, so 2x dx is dt. Sorry, 2x is t, so 2 into dx is dt. So dx is dt by 2. And when t is 1, x is 1, when x is 1, put here 1, t is 2. And when x is 2, when x is 2, t will be, put here 2, it will be 4. So 1 will be replaced by 2, 2 will be replaced by 4 when converting in new variable. So integral is, see 1 will be replaced by 2, 2 will be replaced by 4, dx will be replaced by dt by 2, and here x is replaced by t by 2. 2x is t, so x is t by 2. 2x is t, so x is t by 2, so putting here t by 2 minus 1 upon 2 into t square by 4 into e raised to t, dx is dt by 2. So convert everything in new variable. There should not be mixture of x and t. Everything in terms of t, hence here value of t. So it is 2 to 4, this is 2 by t minus 2 by t square e raised to t dt by 2, we keep outside. Now look, this is f, function of t, and here this is its derivative. Derivative of 2 by t is minus 2 by t square. So it is like ft plus f dash t. So its integral is, it is equal to ft into e raised to t. Ft into e raised to t. This is integral lower limit 2, upper limit 4. Integral of fx plus f dash x e raised to x is fx into e raised to x plus c. So here I have taken ft into e raised to t plus c, we do not include when finding definite integral. So it is equal to 1 by 2 is common, putting here 4, 2 by 4 e raised to 4 minus, putting it 2 here, 2 by 2 e raised to 2. So this is 1 by 2 times 1 by 2 e raised to 4 minus e square. So here e square common, 2 is LCM, so 2 into 2 4, inside this will be e square minus 2, sorry, taking it to LCM, e square common, so e square is left, minus here 2 will be left, so e raised to 4 by 4 minus 2 square by 4, so e square by 2, so it's okay. Now in this question, method of partial fraction, procedure is same, only extra is put upper limit minus lower limit at last, and we do not include c in this calculation. So here we take 1 upon x square into x plus 1 is a upon x. See here this is repeating, so a upon x plus b upon x square, because repeating, c upon x plus 1, method of partial fraction. So therefore now its LCM is here, so a into what is left from this part is x into x plus 1 plus b into x plus 1 plus c into x square equal to 1. Now choosing x equal to minus 1, put here minus 1, this will be 0, this will be 0, so c is 1. Putting x equal to 0, this will be 0, this will be 0, so b is 1. And now we take x equal to 1, so 1 into 1 plus 1, 2a plus 2b plus c is 1, 2a plus 2b plus c is 1. Now c is 1, b is 1, so 2 into 1 is 2, c is 1 equal to 1. So 2a is minus 2, so a is minus 1. So integral is, therefore integral is, now replacing given expression by new expression, integral is from 1 to 3 a upon x minus 1 upon x plus b upon x square plus 1 upon x square plus c upon x plus 1. C is also 1 upon x plus 1 dx. Now integrals, integral of minus 1 upon x is minus, as it is, integral of 1 upon x is log mod x. Integral of 1 by x square is minus 1 by x. X raised to minus 2, so minus 2 times minus 1 upon minus 1. Okay, it is minus 1 by x. Integral of 1 upon x plus 1 is log of modulus x plus 1. Lower limit is 1, upper limit is 3. Now putting limits, here putting 3 minus log 3 minus 1 by 3 plus log 4. Now putting lower limit, so minus, now, so this was f of a, now minus f, this was f of b, now minus f of a, putting lower limit. So putting here 1 minus log 1 minus 1 by 1 is 1 plus log 2. So this is minus log 3 minus 1 by 3, this is 2 log 2, minus minus plus log 1 is 0, minus minus plus 1 minus log 2. So this is 2 log 2 minus 1 log 2, that is 1 log 2, minus log 3. 2 log 2 minus 1 log 2 is 1 log 2, minus log 3 keep as second term, minus 1 by 3 plus 1. So 1 minus 1 by 3 is equal to 2 by 3. So it is log of, joining these two, log of 2 by 3 plus 2 by 3, it is required integral.